Cyber Threat Hunter is a data fusion approach to defensive cyberspace operations that elevates alerts and warnings from low-level cyber events and signals to higher-level attacker tactics, techniques, and procedures, and course-of-action hypotheses. Hunting is enabled by the same ontology that supports fusion by working backwards from TTP and COA hypotheses to events and signals that could possibly confirm, deny, or support the higher-level hypotheses, and then enabling those collections. Silver Bullet was involved in the development of the data fusion levels by the U.S. Joint Directors of Laboratories and has applied them in innovative ways to many national security challenges, including this project for cyber threat hunting. There are 5 widely recognized data fusion levels that consist of differing data inputs and outputs and algorithmic techniques for refining information to support missions. In a nutshell, DF Level 0 is feature extraction, including detection from raw sensor data such as radar returns, imagery, and cyber phenomena such as netflow, SIEM events, and data anomalies. DF Level 1 is object and event estimation from the extracted features. For radar, this is tracking. For cyber, this is inference of attack pattern steps from the observations and features. DF Level 2 forms linkage hypotheses between objects and events that could be causal, behavioral, mission-related, or otherwise correlated. For cyber, this is inferring attack patterns and sequence hypotheses from the attack pattern steps, i.e. cyber attack behaviors and TTP. DF Level 3 is about prediction, for example, predicting an attacker's intended course of action. DF Level 4 is resource management, that is, tuning the DF processes and sensor source collection to resolve hypotheses, ambiguities, and incompletions in needed mission information. Ship systems resemble industrial control systems in that most of the internal systems are not exposed to the Internet and are protected by many layers. But much of the equipment is specialized and does not run on commodity operating systems and, therefore, cannot support host-based endpoint monitoring, so malevolent behavior induced by cyber attacks can be difficult to detect. If abnormal behavior is suspected, it can require cyber hunting to determine if the abnormality is cyber-induced and to track down the sources of the attack for countermeasures. Zero-trust principles are that boundary protections are not enough in today's cyber threat environment, especially for mission-critical and safety-related systems, such as aircraft, vehicles, ships' weapons, sensors, and spacecraft, and land-based air defense systems, strike systems, tactical and operational command centers, facility control systems, automated warehouses and shipping centers, automated manufacturing systems, power generation systems, and water and wastewater control systems, air traffic management and control systems, port management and control, rail optimization and control, and Internet of Things networks such as medical facilities. This technology will improve performance over the baseline, though newly invented data fusion algorithms, a type of artificial intelligence, to infer attack behavior from observations and features of own assets, so that when a zero-day attack occurs, the DF algorithms will still detect the effects even though the cause is initially unknown. At DF Level 0, AI machine learning uses Elastic and Splunk infrastructure to detect physics-based anomalies. At DF Levels 1 through 3, statistical and probabilistic algorithms aided by a cyber ontology constructed from national threat TTP data sources. At DF Level 4, through an adaptation of information-based sensor source management, a patented technology for sensor and source optimization to meet commanders' information requirements. The measures of operational effectiveness are high probability of detection and low probability of false alarm. This means DF likelihood ratio for true positives is much bigger than 1, and the DF likelihood ratio false positives is much less than 1. The key innovation is DF architecture, algorithms, and ontology solutions originally developed for radar target tracking, adapted to cyberspace, and integrated with COTS big data security information and event management infrastructure. The current status is as follows. The cyber ontology has been constructed and is used by the DF algorithms. Elastic and Splunk predefined detection rules have been integrated into the DF algorithms. A technique has been invented for tractably setting up machine learning jobs and detectors for all interface traffic. DF Level 1 to 2 algorithms have been detected and tested, and discussions and meetings with a program of record are ongoing. Rather than inundating operators with many possible threat alerts, we do the following. Infer behavior and intent of threat, not just indicators and signals. Leverage cyber intelligence from national sources. Chain patterns of behavior across own assets. Rank by likelihood ratio, so strong alerts and warnings can be elevated, and weak alerts and warning can be filtered. Update hypotheses and likelihood ratios in real time, so they adjust to ongoing events. Explain hypotheses to operator. And hunt by enabling DF processes to zero in on threat. A Phase 2 option is needed to support transition into Navy Program of Record. Software currently runs on Silver Bullet test computers and needs to be integrated with Program of Record. This could be done with REST APIs or by rehosting the Silver Bullet software in the Program of Record environment. Navy Ship Systems Operational Technology is a type of industrial control system and supervisory control and data acquisition system, such as those in factories, utilities, and automated warehouses. All these types of systems are vulnerable to cyber attack. For example, through the Internet Gateway or Access Point, malicious code embedded in COTS products, older generation operating systems, or overlooked cyber hygiene such as printers. The ability of DF to fuse low observable signals into further cyber sensor hunting, leading to actionable mitigations and countermeasures, is applicable in these types of systems. Discussions and meetings are ongoing with PEOIWS 6.0. However, this technology is applicable to other enclaves. We are Silver Bullet Solution Incorporated. Data fusion technologies applied to new domains in novel ways. Please reach out to us at the contact information listed on this slide. Thank you for your time.